Hi, my name is Jacob Keip, and today I'll be talking about the return of commercial supersonic travel. As I mentioned in my earlier presentations on this topic, commercial supersonic travel is not a new idea. The Concorde was a supersonic passenger airliner that operated from 1979 to 2003. It could fly from New York to Paris in roughly 3.5 hours. A combination of multiple factors led to the shutdown of the Concorde, but more importantly, the shutdown of the first and last supersonic airliner. One of the main factors was that there was strict regulations in place prohibiting flight of supersonic jets over populated land masses. This limited the Concorde's flights to coast flights. For the past 17 years, the world has been without accessible supersonic travel, and you could probably argue that it's been longer than that. But now, solutions to many of the problems that plagued the supersonic jets of the past are all coming to the surface at the perfect time. Mainly, technology involving reducing the hazards and impacts of sonic booms, as well as sparking a change in the regulations of sonic booms over land, are coming to fruition. While the companies are developing advances in materials, design, and engine efficiency, hoping to make it possible to produce commercially viable supersonic aircraft, I will be solely focusing on how those advances can help eliminate the main problem, which is addressing the sonic boom problem. I'll be talking about some proposed solutions that are being developed in the industry today to address the sonic boom problem. As I said, during the time of Concorde and to today, the FAA does not allow overland supersonic flight. This was because of one, the subsonic noise produced by the Concorde's massive and inefficient engines on takeoff and landing was much more extreme than any other jet at the time, and two, the sonic booms produced by cruise level flight were still very noticeable on the ground and impacted many people's lives and livelihood. This ban effectively grounded the Concorde's flights over any landmass and restricted it to oceanic flights, severely cutting the Concorde's expected flight schedules. In the past 17 years of supersonic-less flights, technology has been pushing forward the reduction of the impact of sonic booms. So in October 2018, Congress passed a bill stating that the FAA would have to review their policies regarding commercial supersonic travel. It stated that the FAA would work directly with shareholders in the industry to evaluate the safety and benefits. They would consult over noise issues between subsonic and supersonic aircraft. It also requires the FAA to develop noise standards for sonic boom over land and for takeoff, and landing noise test requirements for civil supersonic aircraft. Most importantly, beginning December 31st, 2020, and every 2 years after, the FAA is required to review current aircraft noise measurements to determine if the regulations should be changed to remove the ban on supersonic flights over land. The passing of this bill not only shows that the FAA is keeping a very open mind when it comes to terms of allowing supersonic flights, but it also opens the door for companies to see that can become a worthy investment to develop these technologies further with lower risk of them getting shut down by the FAA. Enter the NASA X-59 Quest, or Quiet Supersonic Technology Demonstrator. It is a testbed being developed by Lockheed Martin. Its main purpose is to demonstrate a much quieter sonic boom over land when compared to the Concorde. The goal is to reach perceived decibel levels below 75 decibels, which is about equivalent to the sound of you slamming your car door. The knowledge to be gained by this project will hopefully be applicable to the reversal of the FAA bans of supersonic flight. The X-59 will utilize many unique features in order to achieve much lower sonic booms. To do this, Lockheed Martin is designing the aircraft so that the shock waves produced by different components like the nose, wings, and engine spread out, producing a longer but quieter thump instead of a large and abrupt boom. You can see some of these components on display in this graphic. Some things worth pointing out is that all the lift surfaces like wings and canards all lie in a different plane from each other. This helps prevent the coalescing of turbulent flow over these surfaces. Also notice that the delta wing design is very similar to the Concorde, as well as the bullet-shaped nose. This prevents air and pressure from building on as minimal leading surfaces as possible. Also, another thing to note is that the X-59 utilizes a front viewing camera system since the nose doesn't allow any forward-facing windscreen. Without a windscreen, the X-59 is allowed to have much less buildup of pressure on its surfaces of the windscreen. Assembly has already been started on the X-59. In order to save time and major costs, the aircraft will be reusing many different parts from other aircraft from NASA and Lockheed Martin. For example, its landing gear are from an F-16, its control stick from an F-117 stealth fighter, as well as many other repurposed parts from various systems and aircraft. Designing and building these parts new would cost millions of dollars and many years more time. Since there will only be one X-59 built as a prototypical testbed, it takes more sense to use the existing components instead of producing brand new parts. In September of 2019, the critical design review was completed and the aircraft was cleared to proceed with final assembly. The first flight is scheduled for 2021. This brings us to the XB-1. The XB-1 is also a testbed being developed by Boom Technology. Instead of demonstrating a quiet sonic boom like the X-59, its main purpose is to act as a proof of concept for its planned commercial equivalent. The XB-1 generally follows the same model as the Concorde, high thrust engines and delta-shaped geometry. In other words, there are no planned changes to overall loudness. This time, with the recent technology leaps, they plan to have much more efficient engines as well as being able to reap the benefits of a composite airframe, which will cut down severely on the weight. Boom Technology plans to use the XB-1 as a 1/3 scale prototype for their true supersonic airliner, the Boom Overture. The XB-1 is scheduled yet to fly in 2020, but it has many milestones to complete before reaching flight worthiness. Shown here is the fuselage in its current state as of March 2020. Also, Boom Technology is a relatively new startup that is privately funded without a proven track record like NASA and Lockheed Martin has. The project has pushed back deadlines a few times, so whether it will fly this year is yet to be seen. This leads us to the successors of both the prototypes we just discussed. I won't dive too much into the details of these aircraft because they're both very much conceptual at this point, but they'll both be heavily relying on the results of their respective test beds for future performance. Shortly after the assembly began on the X-59, Lockheed Martin announced the concept of the Quiet Supersonic Technology airliner, which is planned to utilize the quiet sonic boom technology of the X-59 so that it can fly over land. The Overture, however, is planned to only fly oceanic routes and is planned to start out as a long-range business jet, then scale to an airliner. According to Boom Technology, the Overture will build off of what a Concorde started by improving efficiency over the Concorde's airframe and engines, which will reduce operating costs enough to turn a profit at business class fare levels. This was actually a problem of the Concorde as it was barely making a profit on every flight it flew. The Overture's planned speed is planned to be at Mach 2.2, much faster than the planned Lockheed Martin aircraft. Boom Technology states that the Overture will not require afterburners like the Concorde did, which will drastically reduce the takeoff and landing sound that it produces, attributing these successes to the 5 decades of technological progress in propulsion design. However, the Overture's testbed, the XB-1, will be utilizing afterburners to fly supersonic. With NASA's and Lockheed Martin's proven track record, ability to hit major milestones steadily along development, an innovative plan to work with the new technology of the era, as well as utilizing the FAA's door-opening policy changes, I recommend that the NASA X-59 solution is chosen. If the X-59 can be proven in flight to effectively reduce the impact sonic booms have on the residential population, it far outweighs the Concorde, the Boom Technology XB-1, and any other similar high decibel producing supersonic aircraft. The absolute selling point about the X-59 and its planned commercial airliner is the fact that it has the ability to fly over land and change the landscape of FAA supersonic regulations, opening the market to many other competitors willing to try the same thing. And with that, I'd like to open up to any questions that you guys might have.